this is my 11th episode and we are going to solve more integration by parts problem. This is the last episode of integration by parts. In the next episode we are going to solve some integration by partial fraction. Now we go straight to the sums, and please, if you like my channel, please subscribe and share and comments. And anyone have any problem about the sums, please call me on the phone number. My phone number is 9830495093. Anyone have any problem can call me on that number 9830495093. Now we are going to solve some problems, some important problems by parts about class 12 standard of any board. This is board standard mathematics, not like your JEE, any competitive exam. Just we are doing some class 12 standard mathematics for board exam. In the next we can solve some critical integration for JEE and another competitive exam. Now going straight to the sums. Number one problem today. This is a very big sum. Integration e to the power tan inverse x by 1 plus x square whole square dx. So here we are putting tan inverse x is z. So dz is 1 by 1 plus x square dx. Simply putting tan inverse x is equal to z. So dz is 1 by 1 plus x square dx. Now it can be written as further e to the power tan inverse x by 1 plus x square into 1 plus x square. This is 1 plus x square whole square. So we can write it 1 plus x square into 1 plus x square dx. Now from here we can write tan z is equal to x. So now substitute the value e to the power tan inverse x, that is e to the power z, because tan inverse x is z, and this x can be replaced as tan z, that is 1 plus tan square z. Okay, and now this dx by 1 plus x square, this dx by 1 plus x square, we can write dz. This dx by 1 plus x square we can write dz. So it becomes e to the power z by 1 plus tan square z is sec square z. 1 plus tan square z is sec square z dz. Now sec square z is 1 by sec square z is cos square z. Now taking half e to the power z into 2 cos square z. Now this becomes half integration e to the power z into 1 plus cos 2z. Now this is taken as IC. Okay, this is taken as I. Now split it. Just separate from this here. We are going to here integration. Half integration e to the power z plus half integration e to the power z cos 2z dz. Simply split separate e to the power z and e to the power z cos 2z. Now we have to integrate by parts in this part. E to the integration of e to the power z is only e to the power z, so it is no problem. Now let e to the power z, and this is taken as I1, where I1 is integration e to the power z cos 2z dz. Now this is by parts using I1 is integration e to the power z cos 2z. Okay, using integration by parts rule and IMF rule, d dz of cos 2z integration e to the power z dz whole dz. Integration of e to the power z is e to the power z minus ddx dz of cos 2z is minus sin 2z by 2. So minus minus plus half sin 2z, and integration e to the power z is e to the power z e to the power sin 2z dz. Now again by parts this. So it becomes e to the power z cos 2z plus half into sin 2z. This is by parts. Integration e to the power z dz minus dz of sin 2z integration e to the power z dz whole dz. Closing the bracket. Closing the bracket. Now this is e to the power z cos 2z plus half e to the power z sin 2z. Sin 2z differentiation is sorry, this is something going wrong. This integration, something going wrong. So again we differentiate it. From this line we start again. E to the power z is e to the power z cos 2z minus differentiation of cos 2z is sin 2z into 2, not divided by 2, into 2. So this becomes 2 e to the power z sin 2z. Okay. Differentiation of cos 2z is minus sin 2z into 2, not divided by 2. Wrongly stated earlier. So this is the new thing. Now again by parts this. E to the power z cos 2z plus 2 integration sin 2z again by parts integration e to the power z dz minus dz of sin 2z integration e to the power z dz whole dz, and close the bracket. Now e to the power z cos 2z plus 2 e to the power z sin 2z minus differentiation of sin 2z is cos 2z into 2. Differentiation of sin 2z is cos 2z into 2. So 2 into 2, that is 4 integration e to the power z cos 2z. Now we can put it here as I1 because we are taking I1 is e to the power z cos 2z. So I1 becomes e to the power z cos 2z plus 2 e to the power z sin 2z minus 4i1. So it becomes 5i1 is e to the power z cos 2z plus 2 e to the power z sin 2z. Okay, this is becomes again by parts, and we will get this result. So from here we can write I1 is 1 by 5 of that. Now substitute here the values and we'll get the answer. Here we put it in 1. Now value of I1 put it here and we'll get the answer. And so just erase it, erase that part, erase that part, and here from 1 we can write half integration of e to the power z dz is e to the power z plus half into I1. From here I1 we get 1 by 5 e to the power z cos 2z plus 2 e to the power z sin 2z plus constant. Now substitute the value. We have cos 2z is 1 minus tan square x tan square z by 1 plus tan square z, and sin 2z is 2 tan z by 1 plus tan square z. Now we are putting here half. From here z is tan inverse x, so e to the power tan inverse x plus 1 by 10 e to the power z as common, e to the power tan inverse x, sorry 1 by 10, this is 2 into 5 is 10, and cos 2z is 1 minus tan square cos 2z is 1 minus tan square z. We have put tan z equal to x, so tan square z is 1 minus x square by 1 plus x square it is, and this is 2x by 1 plus x square. So 1 minus x square by 1 plus x square plus 2 into 2x divided by 1 plus x square plus constant. This is our answer. You can simplify more there from here. So this becomes half e to the power tan inverse x plus 1 by 10 e to the power tan inverse x, 1 plus x square is LCM, 1 plus 4x minus x square plus c. This is our answer. This is a long process, long time problem. This is, if it will come in any class 12 standard, it will give you 5 to 6 marks. It's a long problem. Okay, this is my first sum of today. Now we are going to second sum. This sum is very, very important for any board standard. Now we are going to solve another problem. This is very, very important for any board standard of class 12. Once again I repeat, if anyone have any problem about the maths, can call me at that number. Okay, please subscribe and share my channel and comments. My next problem, very, very important problem. This is number 2 problem of today. Sine inverse root over x plus a plus x. Very, very important problem. Same type of problem, cos inverse root over x plus a plus x. This is same type problem. Same type problem. Sin inverse root over x plus root over x by a plus x, and this is cos inverse root over x by a plus x. Same type problem. In that problem, we have to put x equal to a tan square theta. We have to put x equal to a tan square theta. Okay. So dx is twice a tan theta into sec square theta d theta. Okay. We have to put x equal to a tan square theta. So dx is twice a tan theta into sec square theta. Now substitute here. Sin inverse root over x is a tan square theta by a plus a tan square theta, and this dx is replaced by 2a tan theta into sec square theta d theta. Now this a outside the integration, this is constant. Sin inverse root over a tan square theta, and taking a as common, 1 plus tan square theta is sec square theta. Okay. Taking a as common from the denominator, that becomes 1 plus tan square theta, that is sec square theta. Now it becomes 2 tan theta into sec square theta d theta. Now a cancel, tan square theta by sec square theta. Tan square theta is sin square theta by cos square theta, and sec square theta is 1 by cos square theta. So cos square theta cancel, it becomes sin square theta. So tan square theta by sec square theta is sin square theta. So we can write it root over sin square theta. A cancel, 2 tan theta into sec square theta d theta. So this becomes sin inverse sin theta into 2 tan theta. Sorry, 2 taking also outside the integration, that is constant, into tan theta into sec square theta d theta. Now we know sin inverse sin theta is only theta, tan theta into sec square. Now we have to integrate by parts. Now we have to integrate by parts. From here we can write here 2a theta integration tan theta into sec square theta d theta minus d theta of theta integration tan theta sec square theta d theta whole d theta bracket close. Twice a theta, this is d of tan theta, tan theta, and d sec square theta d theta means d of tan theta, minus d theta of theta is theta, d theta of theta is 1 into, this is integration tan theta into d of tan theta d theta twice a integration of tan theta d theta. If we consider tan theta is x, so x dx. If we consider tan theta as x, so x dx, that is x square by 2. So that integration is tan square theta by 2. Okay? If we consider tan theta is x, so it becomes x dx. So integration of x dx is x square by 2. So it is tan square theta by 2 minus tan square theta by 2 d theta. Now multiply 2 cancel a theta tan square theta minus a, we can write tan square theta as sec square theta minus 1. So a theta tan square theta minus integration of sec square theta is tan theta, integration of 1 is theta plus c. Now substitute the value. From here we can write x equal to a tan square theta, and from this x by a is tan square theta. So tan theta is root over x by a. So and theta is tan inverse root over x by a. So here a tan square theta is x and theta is tan inverse root over x by a minus a into tan theta. Tan theta is root over x by a plus a tan inverse root over x by a plus c. Now from here and here we can take taking tan inverse root x by a as common, we get x plus a tan inverse root over x by a minus a by root a is root a, that is root x plus c. This is our answer. This is very important sum. This is very important sum for any board standard. Okay, this is very important sum. Still we have CBSE and West Bengal Board Maths exam. Already ISC Maths exam is held on 3rd March. So for especially CBSE and West Bengal Board, it is very important sum. It is very important sum for board standard. Okay. This is very important sum about board standard. Now it is it. If we have the integration cos inverse root over x by x plus a, then it is easier to solve if we put x equal to a cot square theta. Okay? You can put it here x equal to a tan square theta, problem will be okay then. But if we put x equal to a cot square theta, it is easier to solve. Same type problem, that type of that problem, just put x equal to a cot square theta. Okay? Now we can go to another problem for by parts. One or two problems, then we conclude our by parts part. My next problem is very simple problem. Number 3, integration root over 4x square minus 9. This is by using direct formula. I have written 3 formulas in the previous episode. In the previous episode, when we start integration by parts, we wrote 3 formulas. Of this, one of these, it can be solved just taking 4 as common. It becomes x square minus 3 by 2 whole square dx. Now 4 becomes x2, and this is direct formula, root over x square minus a square dx. We can use this formula, root over x square minus a square dx integration. This is x by 2 root over over x square minus a square minus a square by 2 log x plus root over x square minus a square plus c. Now using this formula, this is x by 2 root over x square minus a square minus a square by 2 log x plus root over x square minus a square plus c. This is our answer. We can simplify more and more then, but this is the main thing. Minus 9 by 8 log plus c is your answer. Very simple problem, just using the formula. Okay. Now my last problem of integration by parts. Integration by parts. My last problem is again, you have any problem about the sums, about integration by parts. If you have any problem on integration by parts, you can call me on that number 9830495093. Okay. Now here we can do it by this method. Differentiation of x square plus x plus 1 ddx of x square plus x plus 1 is 2x plus 1. Now we have changed it as 2x plus 1. 2x minus 2 divided by x square plus x plus 1 dx. Now it can be written as 2x plus 1 minus 3 now separate. Half 2x plus 1 root over x square plus x plus 1 minus 3 by 2 root over x square plus x plus 1. Now this can be written as 2x plus 1 dx. 2x plus 1 dx is d of x square plus x plus 1. 2x plus 1 dx is d of that. So we can write it root over x square plus x plus 1 d of x square plus x plus 1. That is 2x plus 1 dx. 2x plus 1 dx we can write in this form. And this is by whole square form. We can write x plus half whole square plus root 3 by 2 whole square. X square plus x plus 1, we can write it x square plus 2 into x into half plus half square, and we add 1 by 4, subtracting 1 by 4, so it becomes x plus half whole square plus 3 by 4, that is x plus half whole square plus root 3 by 2 whole square dx. So by integrate it, integration of root x is x to the power half, so it becomes x to the power half plus 1 by half plus 1. By this method we have written is that 3 by 2, 2 by 3 x square plus x plus 1 whole to the power 3 by 2 plus, minus. Now using this formula, x by 2 root over x square plus a square plus a square by 2 square by 2 log x plus root over x square plus a square plus c. This is our answer. We can solve boldly, simplify just. So we conclude my by-parts problem. In the next class, we are going to solve some integration by partial using partial fractions. If you like my channel, please subscribe, share and comment. And anyone have any problem with the sums can contact me on that number 9830 495093. Thank you for the day. Okay, thank you for the day.